and welcome to the ARM What Is Program series. In each episode, we explore a tech topic to give you insight and perspective into some of today's hottest design trends. I'm Brian Fuller, editor-in-chief at ARM, and today we're going to find out what is computational storage. And to help us with that, I want to introduce Jason Molgaard in Kshitij, Sudan. Jason is Senior Principal Storage Solutions Architect with ARM's Automotive and IoT Group, and Kshitij is Director, Storage and Accelerator segment with the same group. Now, when they're not helping us understand what is computational storage, Jason enjoys spending time with his twin boys. Kshitij is an active hiker and backpacker and has bagged a number of 14,000-foot peaks, including Mount Elbert in Colorado. So, gentlemen, let's get started. What exactly is computational storage?
Yeah, Brian, thanks for the question. So computational storage is the ability to perform computing tasks closer to or on the storage device to reduce data movement and or offload the host CPU. A small number of additional ARM processors are typically added to the existing controller for performing these computations close to the data.
So what benefit does that proximity with computational storage deliver at, say, a system level?
So great question. So there is a significant amount of data that's stored on drives nowadays, and we continue to store anything and everything as a society. Traditional storage devices require all of this data to be transferred to the host for processing. Computational storage saves the bandwidth and power of moving all of that data to the host for processing, while simultaneously enabling the host CPU to work on other tasks. The system PCIe bus bandwidth demands are reduced, and the host CPU demands are reduced. This is a clear win for the system.
So what does this mean to, say, enterprise or hyperscale data center architects?
I can take this one, Brian. So for the enterprise and data center architects, one of the biggest advantages of computational storage is to reduce the total cost of ownership, because now you have your processing elements closer to the data where the data is stored. Like Jason was highlighting, you can basically remove all the unnecessary movement of data, thereby increasing the energy efficiency of processing and at the same time unlocking new functionalities. So the three big things would be the TCO advantage, the new functionality that can be added with computational storage, and increased energy efficiency. And of course, we know with increased energy efficiency, you can make your data center greener.
So we've worked a lot as an industry and as a company in the last few years to distribute compute from the cloud out to the edge and endpoints in a more efficient way. How does computational storage help to drive that?
Oh, that's a wonderful question, Brian, because, like you mentioned, compute is now happening everywhere, from edge all the way back to the cloud, right? But with the onslaught of technologies like 5G and autonomous cars, where more data is being generated on the edge, it's nearly impossible to take all that data and transport it to the cloud for processing. This is a real value add of computational storage, where you can actually process the data closest to where it is generated on the edge. And then you can send the aggregated results or the insights that you have collected from that data back to the cloud for further processing. So in some sense, I would say computational storage is almost a necessary requirement and a natural fit for edge processing.
So how do you see it evolving as a technology in the coming years?
So right now we are at a very exciting stage in computational storage. This technology is just starting to be both researched and adopted in certain use cases. But in the near future, we can expect computational storage drives to start looking more and more like a traditional storage server, for example, specifically with things like accelerators for machine learning and AI, because a lot of the processing on the edge that is happening is all about understanding the incoming data streams using AI and ML methods. So we can expect accelerators to show up in computational storage drives very significantly. The other big thing we are expecting is around the software ecosystem. So right now the technologies are in their early stages, but we definitely expect maturity in the software ecosystem for specific tasks that can be executed on the computational storage drives. And the final piece is around security. You can imagine as more and more data is being generated, it has to be kept secure and certain things need to be anonymized, right? This is exactly where computational storage can help, because it can help you implement both compliance to regulation, things like GDPR, and it can also basically ensure that only the data that you need to see as a user is accessible to you and not everyone else. So security and protection and compliance to regulations are another area where we expect this technology to grow.
There is a huge amount of value in that. That's amazing. Let's close it out with one last question for Jason. How does ARM support computational storage?
Yeah, great question. And so actually ARM supports from a number of angles. So beyond providing ARM cores for the compute in a computational storage device, ARM is active in the standards bodies that are defining the computational storage standards. And we're helping to drive those standards to closure so that everyone is designing something that will be compatible with all of the systems and servers out there. And we believe at ARM that this standardization is the pathway to adoption and widespread deployments. So in addition, ARM is also helping to enable the ecosystem with software stacks and solutions, as Kshitij mentioned, to boot these ARM processors and run standard open source operating systems and applications on the computational storage drives. We want to make it easy for our partners to focus on the aspects of their design that differentiate their product from other vendors and leave the non-differentiated aspects of their code to ARM.
Well, thanks, gentlemen. That was insight into some amazingly transformative technology, and I look forward to seeing it evolve in the coming years. Now, check out all our other What Is episodes here, and be sure to subscribe to this channel because we'll be adding more as the year progresses. Thanks for listening.